Okay, welcome back to the second of four videos for the second lecture in CPD 710. This is just as a recap, we're talking about it's really a reappraisal of your construction knowledge, just to remind you of what you've probably covered already, and then we just get prompts in terms of little things or important aspects that we shouldn't forget. But I think sometimes we as we continue and we've covered it in previous theory courses, we simply assume aspects to be in place. Again, this is really the basics of timber. For instance, we are going to talk about the high-tech technical solutions or innovative solutions in following lectures. In this video, we are going to cover timber, masonry, really briefly. I think masonry is quite well understood, and then concrete structures. So timber is, I think, a material that hasn't been used extensively in South Africa up to now. Interestingly, internationally, it is growing significantly as a construction technology, and it's also been it's also been uh, it's been used extensively in places such as North America, Canada, um, in some of our Scandinavian countries where there are this abundance of timber as a resource, you know. So I think it's from a vernacular point of view, it's been used in a number of places extensively. But we are seeing I would say a resurgence into timber as a construction system, as a modern technology, and we often then start talking about engineered timbers, where we start saying that we are looking into ways of ensuring the quality is homogeneous throughout, that we can actually start using it for its benefits that it provides to users. Um, Within and there's a number of benefits in the end, ranging from its tensile strength to the biophilic capacity elements to it, to the fact that it actually stores carbon, so it becomes a more sustainable, renewable material. So there's, I mean, in that way, I think it's a non-brainer that we should start looking into it. In South Africa, though, and especially if you work in the central parts of South Africa, so Gauteng, Northwest, Mpumalanga, and so forth, it's not used as much, and it's related to a number of reasons. I think part of it is the industry that hasn't developed as much, but it's also very dry and very hot in this context, and we've got a very high UV rating, so lots of sunlight, and those are in so dry conditions and conditions with high UV qualities are actually quite damaging for timber, and needs to be dealt with appropriately. So we often find timber structures more in humid conditions where it's not as rough, and where it's a little bit more overcast in those conditions. So something to just think about whenever you're designing in very harsh conditions, as we would find in the South African interior. Um, Something to think about then when you are working with timber, you can't simply chop off a tree on site today and saw it into planks tomorrow, and then you sort it. Timber actually gets treated extensively. It has to be dried. That often takes a long time. These days they use kilns as well to get the drying process, speed it up a bit, and then it has to be preserved and finished and cut into pieces and so forth. So it's a bit it's not when you say that it's harvested on site, I mean, you have to understand the implications thereof in the end. But just something to think of. Then remember, as similarly to steel, unlike concrete, which is very flexible, timber also comes in specific sizes, and you can go and have a look at it. I know the Architective has a lovely little table that shows all the sizes, but it's typically a 38 or 50 depth and then it has a 38 by or 50 or 76 or 114 or 228 size in terms of the plank that it gives, and it's important to understand those sizes, and then if they get plain, they're actually a little bit smaller as well. So you can go and cut timber, but if you're designing something that's 110 mils or 108, and which means every single plank now needs to be, you need to go and cut 6 millimeters of the steel of the timber plank or component, because the designer only allowed for 106 mils. I mean, you've got to think carefully. Why do you end up choosing? Why do you choose that size and not simply use the industrial size that's available at the moment? Remember that the timber then also has, as they are, as they come in specific sizes, they also are, they have specific standards in terms of the strength. So there's standards for them, and they come in S5, S7, or S10 size strength. So you want, which is good. So if they um, they often just get a stamp on that says S5, S7, and S10. If that is certified, you know that you're getting good quality timber. So it's certified wood. Also look at the origin of the timber. So we talk about FSC timber, forestry stewardship programs. So um, there you want to be careful about getting exotic woods that have been harvested in countries where you're uncertain about the origin of it, because it actually has major implications um, for those countries and the forests where they get harvested. And often there's little sustainability to that, because if you are saying it's a more sustainable product, it has to be sustainably grown to be sustainable. So something to think about in the process. Then we do, we've got specific sizes, but you can actually move into what we call engineered timbers. Although before that, we actually talk about glulam beams or laminated timbers. So that's when you start sticking, you start gluing pieces together to make very deep beams. For instance, that's often used for beams. And the nice thing is, it's timber can be very homogeneous in its quality if you don't have to go for very long, big pieces, because wood obviously has an heterogeneity in terms of its quality. But laminated beams therefore allow for that. And then when you start using engineered timbers, we'll talk more about that in future lectures. Then actually um, it actually becomes quite valuable. Then you compose timber sections together, and then you start managing the strength of it, and but then you're not dealing with wood that's been cut from a tree, and it shows a grain in the end. It's actually engineered in that way, so it's a bit more uh, um, um, what one would say, um, it's, it's a bit more synthetic in the end. Then also remember, you can work with gum poles. Often we use that. Gum poles are quite robust materials, also a bit more affordable. But remember, you can't necessarily specify the size of a gum pole accurately because gum poles taper. And that means also in the joint, you have to allow for that flexibility of having a thinner and a thicker gum pole. And so we often then allow gum poles to overlap and extend beyond an edge, and you've got layered processes of fixing it together, and you use threaded bolts often to deal with the different depths in the end. Most timber joints, though, are are mechanically fixed, but you can go and have a look at the work. And there's a beautiful project by Kingu Kuma, The Nest We Grow, where they explore ways of fixing the joints of timber, not using mechanical or steel joints. And I think that's actually quite exciting. But it's certainly way more expensive. So you can go for simple mechanical fixings, and there you can use you'll use steel that just shouldn't rust if it's wet conditions and so forth. But it's quite simple in the process, and quite easy to use. Last thing before we continue to the next slide, if you're building a timber structure, remember you have to use insulation. Timber is not as insulative. It has some mass to it in terms of it gives you fire proofing, because timber, if you use thick, big timber sections, um, massive timber sections, effectively, um, then there's a limit to how deep it can actually burn, and the burning layer itself gives some protection. But you must use insulation, and once you use alternative insulation, remember to use vapor barriers. That's on the outer layer of a wall, and between the outer, I would say the timber paneling, that's the waterproofing, to use something that's a wind barrier, and then also prevents any vapor from building up in the insulation, because that damages the insulation in the process. Um, when we talk about we spoke about timber sizes and the fact that there's only some of them available, but it doesn't mean that you can't design interesting ways of fitting it together. I mean, so it is flexible. It can be bent. It can be folded in the way that it can be fit together. So you can explore multiple ways of using it, um, and that's, I think, really exciting in the end. But before you get there, you have to think about how do you preserve and treat timber. Now, it's actually a two-phase process. All timber must be preserved using creosote or, or CCA or boron, and that's often it's a highly chemical, highly poisonous um, solution that it's either dipped in or painted on, and that's the first thing. So that often deals with organic damage or insects and so forth. But then often we still need to use a second preservative process where we would paint a protective layer on top, and you will seal it effectively. And that's what we often know. Timber Life and um, I mean, there's a lot of different products. One is Timber Life, for instance. Dulux makes some and so forth as well, where it's really about a preservative that you paint on top after the first, um, the initial CCA treatment or that you've used. When you use something like creosote, which is the black paint that's often used for gun poles, you'll remember it smells quite a lot. It's dark black. It's like quite sticky. There you don't actually use a second layer on top because you can't paint on top of that. It's sealed altogether, but it's not always comfortable to use. And so, this as a seat would not, creosote will make it impossible to sit on. So you'll use that with CCA, which is a green tinge, greenish kind of surface, and that could actually, but then you have to actually preserve it. And then you can look at sealants that are either oil-based, that you simply paint on and it is absorbed, or one would say a polyurethane-based, where it's actually a sealant that's painted on top that then hardens. It's like you all know, varnish is really on top of it, and those have to be fixed and preserved quite often. So every few years you need to sand it off a bit and then paint it again to keep it. So think about where you install the timber and how you can actually access it later, to ensure that it is still useful after a number of years, because that's one of the major implications of using timber. Um, but timber is really, I think, a very nice material to use. It's quite flexible in how you can work with it in multiple contexts. If you look at these, I mean, you can in these sites, and these are photographs that Aubrey Crawford shared with me. So thank you, Aubrey, for these photographs. You can see them using it in context that's really isolated, and you can still work with the power tools. Isn't as intense to use, and it's quite easy to get it to site, and it's quite flexible. You can insert it in really complex such contexts. Again, you have to think about those joints, the edging that you deal with. How do you deal with these final little bits that possibly can actually damage, and in the end, how do you deal with water buildup? So the one thing you don't want timber to do is to stand in water, or to fill up and be exposed to extended periods of moisture. But as you can see, it could be used quite nicely with mechanical fixing and steel in the end, and you can use it to articulate those joints and use those overlays. Here you can see the gum poles overlapping each other, so to give you the flexibility when you are fixing them together. We'll talk more about it, but think about how you allow it to join the ground, how you fix it onto the ground when you use gum pole structures. When we start talking about decking, decking is a bit more difficult and it's quite expensive, so one has to be careful of that. The first thing to remember is the typical saligna or pine timber that we often use in houses, often used in interior spaces, isn't as great to use as outdoor decking. It gets damaged by the sun and dry conditions quite easily, and that has to be treated often. So every few years you have to sand it off, reseal it, and whenever you cut it, those exposed sections will actually be has to be sealed again as well. That's the thing about timber; you have to seal it completely. Um, you can look into other timbers such as belau or Rhodesian teak, which is a hardy and hardwood, often works as tropical, coming from more tropical forests, and those are very nice timbers to use because they actually they often have an anti or insect repellent in its wood already, so insects don't like it, but they're very hard, so the sun and dry conditions don't damage it. So often you can, like belau, you could simply just use. You don't even need to treat it. But be careful. Those often come from endangered woods and so forth. So there's an implication of using hardwood. Another option is to look at modified timber when you start using heat-treated, resin-impregnated timber. So what they do is they use, so Rhino Wood's a company that uses that, for instance. They use pine, normal pine, and they put it in under very high pressure, high heat conditions, where they actually change the molecular structure of the timber. So it becomes more of a hardwood. And in the process, they will also impregnate with really high with resin products, so that becomes preserved completely. And should you cut it and you don't have an edge that's not protected, and those timbers normally last quite well, but you have to be careful because they actually have significant. When they there's a high energy input into those timbers, and when you discard them, remember they're resin impregnated, so you can't simply just throw it in the felt and it will rot away. It's not going to rot away. It's got a petroleum-based product in it, so think about the end of life of that in the end. Um, and then again, this is just a nice table you can have a look at. Talks about the different preservatives that we can use, and you can see that the relation between creosote and CCA, and you can see creosote has some implication in terms of the color, the odor, which is strong and oily, so it's not great to touch and work with. CCA is a bit better, quite easily to use, TBTOL and boron as well. Um, when you think about preservatives, go and have a look at, there's online quite a number of the South African Wood Association or Timber Association has a number of resources on the preservation of wood, because remember, you need to understand the condition where you'll be using or the context. If you're using it above ground in dry conditions, it doesn't need as much preservatives as you would be using it underground or in wet conditions or in salty conditions, so next to the coast. If you're next to the coast, then you have to use creosote and CCA together, and it's intense preservative that you need to use. So have a look at it. There's a lot more information on that, but understand where you're using it to understand how much you actually need to use. Remember, when you're using it indoors, then it's significantly less preservatives needed than when you're using it outside. And typically also when you're using it on the southern side of the building and it's more shaded, again, you can actually carefully, you can use less preservatives, or it will last longer when you use it. So think carefully about that. Then last thing is, when you use gum poles, remember that gum pole structures typically start what in a sense delaminate, or they turn and twist as they dry out, and you'll start them splaying in a bit. So you start seeing the timber like these little fingers and sticking out from the edges, and that's actually the problem of gum pole structures, or specifically Saligna gum poles. So it's best to use end plates. It's a nailed plate that you put at the end of a timber piece, or you take a piece of wire and you bind the edges, and then you know that they will last. And then they last very long. So if you don't do it, it's interesting about timber. If you preserve timber, it actually lasts for a very long time. If you don't, it doesn't at all, and you'll see a few years and it will be gone. Then talking about masonry structures, I think I'm not going to spend too much time on masonry. I think you all spend a lot of time working with it, and most of the offices use masonry extensively. So I'll be very quick. Just to remember, these often refer to stereotomic structures. These are structures that are, if you can think about monolithic structures, another word you can use for that. So it's not often used for more than two-story buildings. Then, if you go any higher, you actually have to start using it as a frame system. I know there are engineers that use masonry in five-story buildings and so forth, but it's very specific ways they design it, and they specify the brick specifically and the concrete, the cement that you use as jointing. It specifies specifically. And then there's a number of ways of using buttress walls and so forth, and the thickness of the wall. So it's typically not done. Typically, you use a concrete frame structure and use masonry as infill, which I think is a bit more effective way to use it, but it's a bit more expensive. Um, so that's the one thing, but that actually gives it that stereotomic quality of it gives it quite a lot of flexibility. And we know that they come in specific modular units. So typically, like a 222 by 106 by 73. We know that's the size of a clay brick, but we typically say it's a 110 by 220 by 85. So we include the cement joint in the process. We talk about brick courses. Um, but remember, when you cement blocks, that's actually a different size. There can be many different sizes. It's a bit higher, bigger blocks in the end. But even though they come in these modular units, which gives you a little bit of restraints in terms of how high and how wide you can go, you have to remember that these still it's actually quite a flexible material because the unit is so small, you can easily break down a piece of the wall and fill it in there and build it up again. You can do quite a lot of, you can do curved walls and so forth, or arches, which in other structures like timber is not always that simple. But remember when you do use it, there's ways of finishing it. So we can use face bricks, big bricks to do it. So in face bricks for face bricks you start having different standards for the bricks: FBX, FBA, and FBS. You can go and search it, but it actually starts talking about how homogeneous the colors are. And remember that the bricks relate to its origin. So in different countries, we have different colors of clay, and that leads to different types of bricks colors that we get. But either way, face brick is a very hardy way of finishing a building. They don't need to be painted or fixed again, and they can be done quite beautifully. If you look at these images here, that's ways of using face brick. But you can also paint it, which is also quite nice, or you can plaster it. When you plaster it, think about the joints in the end, and plastering is a bit more, can be damaged over time and have to be replastered, and it's another phase you have to add to it. So it has cost implications. Remember, when you've built a brick building like this, a face brick building, adding or taking away from this is quite tricky because the color and the brick needs to match. So think carefully about what the implications are there. Um, when we use bricks, remember you can define the joint and the bond in the end. Go and have a look at that. So deeply recessed, flush joints, um, and that makes a big difference in the end. If you, it, the part of that, you also need to think about the strength. So remember that we use brick force to ensure that they are strong enough. And the brick force is actually like it's steel reinforcing. We put every 5 layers of bricks or every um, um, of brick courses, we lay that to join and ensure that there's some tensile strength for that wall. Or you can use wall ties. And they define actually wall ties per square meter. So between 2.5 to 3 per square meter. Um, and that's something that's a bit more difficult to check as an architect. And then we can build, we often use precast concrete lintels or timber lintels, or you cast the lintels in place. But you can also use brick lintels. There's limitations to how far it can span, and we often use that with specific bonds. So we use it with solder bonds, for instance. So it's when you put them on the uh, so they horizontal, vertical, really, the brick entity, and that will be integrated with brick force, or you can even use steel reinforcing. And I know of places where we've used steel flat pieces that will just fit in below to keep the brick in place. So there's quite a lot of options there that you can use. The one thing to think about in terms of masonry is that there are certainly limitations to how high you can build a masonry wall and how long you can build it without having brace walls or buttress walls and so forth. So go and have a look at that. It's specified in the SANS standards, but don't forget that. We spoke about the plastering of it, whether you can use bag washed plasters or smooth plasters or scratch plasters. All of them have different ways of articulating it. It's simply beautiful the way you can use it, but you must define it and you specify it when you design it, and don't ignore it in the end. Um, okay, so then when you think about um, materials or stone material, or not materials, when you think about stones or stone construction, we don't use it that much anymore as a stone building that's made clearly, out of it. We actually use it often more as an exterior cladding, which you would see in this image here, and it's just a cost implication. But in the past, we used to use it more extensively. The first thing to understand is that the different types of stone actually has different properties to it. So an igneous stone, which is granite or marble, I mean, they've undergone some extensive pressure and heat to change into stone, and they're very hard to work with. Granite, for instance, is extremely hard and heavy materials, so it's not easy to adjust or change on site, but it has that quality because it's so hard. It's actually quite stable under various moisture or heat conditions, so it doesn't move and shift as much. Metamorphic stone, often we consider that as slate, so it's gone under a bit of a different process of changing after being made into stone effectively. And slate is great, except that it does start to delaminate slowly. And then we've got sedimentary, that's made from sand that's changed into or fine particles changed into stone. And we know sandstone is a typical example. They're much softer and actually damage over time. So one's got to think carefully if they're using it. Um, then they come in various sizes, and the only advice there would be if you use stone, we don't often cut it into blocks anymore, as you would see here. This is really an expensive process, but you can do it. We often use it as tiles or as thin veneers that we fix on, and that can actually be fixed with simple tile cement. Do speak to the suppliers of the tile to see what's proper needed, because if you start going for very heavy, large tile pieces, then you have to start looking into aluminium or steel brackets that you fix onto the wall, and then you fix the tile onto that. So it's all dependent on the weight of that tile. If you start building a stone wall, I can see here, the best advice is that you start using it from the site itself. Um, and as Aubrey would always say, use the guy that took that the person that dug the hole to collect the stone should be building it, because they need to know what is there, and it takes time. But if you give enough time, you can actually fit it together like a puzzle. Like you see some of these, this is like amazing, and it's not that all these were cut necessarily. It's just the way that it's fit together that gives us this quality. But what's nice about using the stone that's been locally collected is that it actually also relates very specifically to the local color scheme, so it fits really well in the context. So it's something to think about. If you want to have it fit, then you might want to use it. This is, for instance, walls from the Great Zimbabwe structures. Beautiful. It's thousands of years old. It's amazing. But you can go for more finished products, like the Barcelona Pavilion here, or the Familia Sagrada, where you cut and change and morph the stone to fit the design in the end. It's all dependent on the type of finish that you would like to present in the end, and how you can fit it. But yeah, think about the limitations that stone presents, and then also the opportunities that it provides. There's also obviously a number of other products available and building systems, like planted walls. How do you do that? Thatch, for instance. How do you use clay structures, and how do you merge the different types of materials and so forth. So my advice is speak to specialists. Try and, if you can, if it is a specialist product, they'd be more than willing to speak to you. Go to product suppliers. Otherwise, go to locals. Go to, if you see the builder working there, chat to them. They would love to share their knowledge with you. Thatch, for instance, is something very difficult. There isn't much written on thatch roofs. So you have to speak to, you've got to find someone that actually is good with thatch to use them in the end as a builder. So I think there's a myriad of other materials available, but so be observant, and then also speak to those that you identify along in your careers as experts with that material or system. Okay, this is the end of the second video. The next video will deal with typical applications or joints, and then the last video will just recap a few of the important aspects that we've discussed in this lecture, um, and a framework for undertaking construction, um, um, undertaking or, or designing structures using new innovative building materials. Thank you.